In this set of notes, we're going to learn how to solve and graph compound inequalities. So that's going to be inequalities involving and or. It's going to be two inequalities at the same time. So compound inequalities are two inequalities involving and or. So if it's a compound inequality with and, it's going to be the intersection of the two graphs. So it's what they have in common. And if it's an or, it's going to be the union of the two graphs, which is the two graphs all together. So it's either going to be an overlap or it's going to be both. So let's see an example of what this looks like. So for example 1, we're first going to graph x is greater than negative 2. This is something we've been doing. So we start at negative 2. We put an open circle to show that we're starting at negative 2 but not including it. And then we have our arrow going to the right. Then we're going to graph x is less than or equal to 1. So we'd start at 1, we'd put a closed circle, and this time our arrow would go to the left to show that x can be the numbers that are less than 1. So if I wanted to graph the 2 as a compound inequality, so x being both greater than negative 2 and x being less than or equal to 1, I want to imagine these two graphs combined together. And so what that would look like is it would have one bookend at negative 2 with an open circle, the other at 1 with a closed circle, and the two graphs going in between. So this is saying that x has to be at the same time 1 or less and greater than negative 2. So the numbers in this shaded region plus the circle at 1 would satisfy that inequality. For an and compound inequality, you can also write it like this, which we've seen when we did domain and range. So it's the two graphs where they overlap. For an or, we can do the same thing. So I can start with, so x is greater than or equal to 0. I would put a closed circle at 0, my arrow going to my right. So this is showing that x can be 0 and up. For x is less than negative 1, I would start at negative 1. I would put an open circle, and my arrow would go to the left. So this is showing that x can be anything that's less than negative 1. For an or, what it's saying is that x can be either of these things. It doesn't have to be an and, it's going to be an or. So what I would do is I would start at 0, closed circle, arrow goes to the right, negative 1, open circle, arrow goes to the left. So you'll see how these two graphs don't overlap at all. And it's saying that x could be either of these two situations. It could be 0 and bigger, or it could be less than negative 1. It's not both. And is saying it has to be both of those things, and this is saying it could be either of those things. So this x could be 3, or x could be negative 5. So our next task is to just translate the verbal phrase into the inequality and then graph it. So we're not solving anything yet, we're just setting it up. So here I've got an and inequality. So I could write it as all real numbers that are greater than negative 2. So I could say x is greater than negative 2 and x is less than 3. I could also write that as a compound inequality. Negative 2 is less than x is less than 3. So the key on this one is that the x is in the middle, and when I read it right to left, this says that x is greater than negative 2, which is what this one says here. So the ands for our final answer, we want to write like this. And so what this is going to look like, it's going to be negative 2, 3, both are going to be open circles, and then I can put my graph in between. Because x is less than 3 would start at 3 and go to the left. X is greater than negative 2 would start at negative 2 and go to the right. The or one I can't write as a compound inequality. I just have to write it as two separate ones with an or. So this says all real numbers that are less than 0. So x is less than 0. Or x is greater than or equal to 2. And so when I graph this, I would start at 0 with an open circle. My arrow would go to the left because that's x being less than 0. Or x is also allowed to be greater than or equal to 2. So I'd start at 2 with a closed circle, and my arrow would go to the right. So in my AND inequality, I can only pick numbers that are within this overlapping region. For my OR inequality, x could be either of those numbers that the arrows are pointing to. Pause the video. I want you to try examples 5, 6, 7, and 8. You're going to create your inequality, and then you're going to graph your inequality. If it's an OR inequality, you're going to write it as two separate ones with the word OR, and if it's an AND, you're going to write it as a compound inequality. One key on your compound inequality is your numbers should always go lowest to highest, and your inequality symbols are always going to be either less than or equal to. Pause the video now, press play when you're ready to check your answers. For the most part, what you're going to find is that your OR inequalities, like examples 5 and 8, are going to have two diverging graphs, and for your ANDs, they're going to be converging, because that's where it can be both types of numbers at the same time. So here for my OR, I've got an open circle at -1, arrow going to the right, closed circle arrow going to the left, closed circle at 4, arrow going to the right. For my AND, I started by creating the two separate. This helped me create my compound inequality, but I've got a closed circle at -3, arrow went to the right, an open circle at 5, and the arrow went to the left, which made this overlapping shaded region. For example 7, my bookends were -4 and 4. Make sure those numbers are going in order from least to greatest, and that it was x was greater than or equal to -4 and less than 4. So I've got closed circle at -4, open circle at 4, and in between. So in between are the numbers that would make x be both less than 4 but greater than -4 at the same time. And then my last one, x can be less than -1 and x can be greater than 2. So here it says a crane sits on top of a camera car and faces the front. The crane's maximum height is 18 feet, so that means it cannot go higher than 18. So I want to think less than or equal to for that. And the minimum height is 4 feet, which means it can't go lower than 4 feet, so it's going to be greater than or equal to 4. So we're going to write a compound inequality that describes the possible heights of the crane. So I might use h for height. So it said the maximum height was 18, so that meant the height can go as high as 18. And it said the minimum height was 4, so that meant if I read this backwards that the height has to be bigger than or equal to 4. So then on my graph, I would have 4 and 18, both with closed circles, and then I've got my graph in between. And so what this would mean is that you would expect the height of the crane to be somewhere in this region. So it could be 4, 4.5, 16, 15. It can't go beyond 18 because the max was 18, and it can't go below 4 because the minimum was 4. Similarly, for the auction, it says the lowest bid was $20 and the highest bid was $54. So we're going to write and graph this inequality. So I might use B for bid. The max was 54 and the lowest was 20. And so I've got a similar kind of situation here. And that means the bids are somewhere in between 20 and 54. So now we're going to get to the solving a compound inequality with and there's a strategy that I'll show you, but there's also a way you might prefer. So the first way is to think of it as solving two completely separate inequalities, almost as if they're unrelated. So the first one would be to solve the inequality 2 is less than x plus 5. And then after I've solved that, I would come back and I would solve the inequality x plus 5 is less than 9. So I could split it into two separate inequalities and solve them each individually. And in both cases, I would get x by itself by subtracting 5. And so for one solution, I would get that x is greater than -3. And in my other case, if I subtract 5 from both sides, I would get that x is less than 4. And so then I can come over and graph that on my number line. So that would be 4 on this side with an open circle. I know my arrow is going to go to the left, and -3 on this side, open circle, arrow would go to the right because it was greater. And so it would look like this. And so what this means is that the numbers that x could be, that way if I add 5 to it, would keep the result between 9 and 2. would be anything between negative 3 and 4, but not including those numbers. So an obvious one seems 0. I could just pick it. 0 plus 5 is 5, and 5 is between 9 and 2. I could try 1. 1 plus 5 is 6, and 6 falls between 9 and 2. So that's strategy number 1, is to just separate them into two completely separate inequalities. Strategy number 2 is to solve it the way it is. You just want to think of how when we solve like an equation, and some people, this is a really simple one I know, some people draw that line and they have to do something on one side of the line, they do it on the other, that golden rule. You could do that same idea here, but the idea is you're drawing two lines. And so, for example, if I was going to get x by itself by minusing 1, well, if I minus 1 on the right side of this line, I would need to minus it over here. But then I also minused 1 on the left side of this line, so I need to minus it over here. So you can see like I drew the minus 1 twice because I'm really doing it kind of twice, because like up here I was solving two separate inequalities. So I minused 1 to get x by itself, I minused 1 because I did it on the right side of this line. I minused 1 to get x by itself, but because I did it on the left side of this line, I had to do it on the right side of that line. So I can draw this. I'm not multiplying or dividing by a negative, so I don't have to worry about reversing my inequality sign right now. So then x is by itself. Negative 1 minus 1 is negative 2. And then 7 minus 1 is 6. So I've got negative 2 on my graph. I've got 6 on my graph, both with open circles, and I can graph in between. Now I also could have split them into their two separate inequalities. So I could have made it negative 1 is less than x plus 1. And I could have made it x plus 1 is less than or equal to 7. Oops, sorry, I didn't realize that was less than or equal to. So I'm going to come back to my graph. Sorry, so I've got to keep that as I draw that, and that means over here my circle would have been closed. Now once I separate them into two, you can see in both cases x is being bothered by 1, so I would minus 1 to get negative 2 is less than x, and I would minus 1 to get x is less than or equal to 6. So you can see how you're getting the same solution as over here, but I just solved it as two separate inequalities, which is a strategy. But hopefully you can see how on this one it has its own minus 1, and this one would have its own minus 1, which is why I drew it twice in the middle there. Let's do one more, and then I'll have you, actually let's try, I want you to try 13 and 14 on your own. You can either do either of the two ways. You can either solve it kind of as one big one, just make sure you're doing it on both sides of each line, or you can separate it into two. So pause the video for examples 13 and 14, press play when you're ready to check your answers. So for 13, it's pretty straightforward. There's only one step to getting x by itself. It's to add 5, and then also to add 5. So that means that x is greater than negative 2, and x is less than 9. So two open circles on my graph with my arrows converging. On example 14, it's a two-stepper. So the first thing to do to get y by itself is to minus 4, and minus 4. So that gets me 6 is less than or equal to 2y, which is less than or equal to 20. Then I still have to divide by 2, and then I have to do it here as well. Divide by 2. So I get 3 is less than or equal to y is less than or equal to 10. So on my graph, I'm going to have two closed circles, and my arrows are coming together. So that means that y can be any number between 3 and 10. So just to see two more, and I'll do 15 and 16 because it has a negative, so that will kind of throw a little wrench into our plans. But so on 15, I would get x alone by adding 8, but then I would also need to add 8. So I think the act of writing it twice really helps reinforce that you're solving two separate inequalities, even if you're doing it as one big one. So then I get negative 6 is less than x, which is less than 7. And so I've got my two open circles, and my arrows coming together. Now on 16, this is actually going to be a two-stepper. So the first thing I'm going to do to get z by itself is I'm going to add 1 on both sides of each line. Add 1, and this is going to give me negative 6 is less than negative z, which is less than 4. Now z is technically being bothered by negative 1, and so to get rid of it, I'm dividing by negative 1, dividing by negative 1, dividing. And because I'm dividing by a negative, I really need to make sure that I reverse my inequality sign. So if I bring that over here, that's going to say 6 is greater, so I switched it from less to greater. Then positive z, which is greater than negative 4. So this looks funny for a couple of reasons. One is we now have greater symbols, and we've been used to seeing less symbols, but my numbers also go in, instead of least to greatest order, they're going highest to least. So if I took this whole thing and spun it around and just wrote it with my negative 4 first, it would say negative 4 is less than z, which is less than 6. And so if you read this one, negative 4 is less than z, that's what this says up here. And this says z is less than 6, which is exactly what that says. So if it's easier, you can see, okay, my pointy side is facing my z when it's with the 6. And my pointy side is facing the negative 4 when it's with the negative 4. So now it looks a little bit more like I would expect. So I've got my negative 4 and 6, open, open, arrows coming together. So you're going to pause the video to try examples 17, 18, and 19. Make sure if you divide by a negative to get z, or the variable by itself, that you're reversing the inequality sign. Pause the video, press play when you're ready to check your answers. So first on 17, you have to add 3, add 3, add 3, add 3. So you get negative 2 is less than or equal to negative x, which is less than or equal to 5. Then you need to divide by negative 1, and because you're dividing by a negative, the inequality signs in both cases need to reverse. So this got me that 2 was greater than or equal to x, which was greater than or equal to negative 5. I'm going to reverse the whole thing. It looked like this. Close circle at negative 5 and 2, arrows coming together. Example 18, minus 3 minus 3, minus 3 minus 3, and then divide both sides by negative 2. So I have to reverse those inequality signs. 1 is greater than x, which is greater than negative 8, and when I reverse it, it's now going in lowest to highest order. So open circles at negative 1 and 8 with my arrows converging. And then example 19, we're going to minus 2 and then divide by negative 5. So because we're dividing by a negative, my inequality signs are going to reverse. You might have put decimals, which technically these fifths decimals do have exact equivalents, but if it was something like thirds or sixths or ninths or sevenths, lots of them, you wouldn't be able to change them to decimals. So I would not. I would leave them as their fractions in simplest form. So I've got negative 2/5 and positive 3/5 because those two negatives here make a positive. And so then I've got my two closed circles with my arrow going to my right, my arrows converging together. I just use negative 1 and 1 as reference points, as like this one was less than halfway and this one was more, but you don't need to do that at all. So now we're going to solve compound inequalities with or, which is a little bit simpler because they are just actually two completely separate inequalities, and they might not even look the same at all, and then you're just putting both graphs on the same graph. So for the first one, example 20, I would start by minusing 3, I get 2x is less than 6, and then divide, and I get x is less than 3. So I'll graph that in a minute. Then for the next one, I would add 6, and I get 3x is greater than 18, divide, and I've got x is greater than 6. So I just come over and I put those two graphs on, and x is less than 3, that arrow is going to the left, x is greater than 6, that arrow is going to the right. So here's my solution. It's saying that x could be either less than 3 or bigger than 6. So for example, x could be 10 or x could be 1. So you're going to just solve each of these. You're literally just solving two separate problems where you're then putting your solutions on the same number line. Pause the video, press play when you're ready to check your answers. So for 21, I solved this one by adding 2, dividing by 3. X is less than or equal to negative 3, closed circle, arrow to the left. Minus 8, divide by 2, x is greater than 4, open circle, arrow to the right. Next one, I minus 1 from both sides. Be careful here. Negative 5 minus 1 is negative 6. Divide by 3, h is less than negative 2. Open circle, arrow to the left. Add 5, divide by 2, h could be greater than 6. Open circle, arrow to the right. Example 23, minus 1, negative 3 minus 1, be careful there, is negative 4. Divide by 4, c is less than or equal to negative 1. Close circle, arrow to the left. add 3, divide by 5, or C could be greater than 4, open circle, arrow to the right. One additional thing just to keep in mind, it didn't happen here, but if at any point you have to multiply or divide by a negative to isolate the variable, be sure to reverse the inequality sign.